Example 2, a particle moves according to the law of motion. S equals 2t minus 1 over t squared plus 1, where t is measured in seconds, s is measured in feet. So once again, we have this law of motion idea. This time they gave us a quotient structure that cannot be simplified. Notice that t squared plus 1 will never equal 0, because t squared is at smallest is 0, and then it gets positive, right? Add 1, now 1 or bigger, so it's never going to cross the x-axis. So this is never 0, so we never have division by 0, we don't have to worry about that. My guess would be if they're giving you a law of motion problem, they're not going to give you anything weird like an asymptote happening. That would be hard to deal with. So I'm going to assume that if there's any quotients, then the bottom thing should not create undefines, at least in the positive region, from 0 to infinity. If there are zeros, they'd probably be in the negative region. We don't worry about those. All right, same 6 questions as the last problem asked us, so they're basically done the same way. The difference is, how do we find a derivative? How do we solve for the function, whatever, that kind of stuff. That's the type of stuff that's going to change here. So, question A, find the velocity at time t. As we can see, this is a quotient, it's a rational structure. I cannot make 2t minus 1 over t squared plus 1 any simpler than that using algebra, so I have to use the quotient rule. T squared plus 1 times 2 minus 2t minus 1 times 2t over t squared plus 1 squared. And the quotient rule is always low d high minus high d low over the square of what's below. Low function, bottom function as is, d high is just 2, right? 2 plus 2 minus 0, so 2. Minus high, 2t minus 1 as is, derivative of the bottom is 2t, and then the bottom squared. T squared plus 1 times 2 is 2t squared plus 2. Negative 2t times 2t minus 1 is negative 4t squared plus 2t. Minus 2t, 2t makes minus 4t squared. Minus 2t times negative 1 makes positive 2t. Again, there's always a minus sign in the quotient rule, and that minus sign is always distributing. Be careful of that. So if I simplify the top as much as possible, once I get the distributive property dealt with, I get negative 2t squared plus 2t plus 2 all over t squared plus 1 squared. So if I know what t equals, I can find the velocity. All right, t equals 0, the velocity is 2 over 1, so 2. Starts off at 2 feet per second. Okay, t equals 3, whatever, we can find that. So part B, what is velocity after 3 seconds? So that's, part B is again just what is v of 3. All right, v of 3 just means to change all those t's to 3's, right? So I'm going to get negative 2 times 3 squared plus 2 times 3 plus 2 over 3 squared plus 1 squared. All right, the top, negative 18 plus 6 plus 2 is going to be negative 10. And the bottom is going to be 10 squared, which is 100. So the velocity would be negative 1/10 feet per second at 3 seconds. All right. Again, velocity after 3 seconds, just substitute t with 3 and work it out. Simplify as much as possible. I'm fine with decimal answers. Typically, talking velocity, we usually go decimal answers on that. So negative 1/10 is fine also, but I'd probably go decimal. So negative 0.1. Question C, when's the particle at rest? Now this is a little bit more tricky than the last one because it's not a polynomial function. It's not even a linear function. This is a rational function. But again, it's just take the velocity function, whatever it is. In this case, negative 2t squared plus 2t plus 2 over t squared plus 1 squared equal to 0. All right. Now this one, you have to remember back in Algebra 1 and Algebra 2. Okay. Maybe even back as far as 5th grade when we first started dealing with fractions. How does a fraction equal 0? What kind of structure does a fraction have so that its value equals 0?
The top is 0.
Top is 0. What's the bottom?
Number.
A number that isn't 0, right?
Mm-hmm.
We already determined that 0 over 0 earlier this year is indeterminate, right? So in order to equal 0, we have to have 0 divided by not 0, right? I've already established t squared plus 1 can't equal 0, right? So the bottom of this thing does not equal 0, ever. So we got the bottom taken care of. So in order to make the fraction here equal to 0, the top of this thing has to equal 0. Because again, the top has to be 0. Alright? So with a rational function, that's one thing you can do to simplify things for yourself. Yeah, the function's supposed to equal 0, but that just means the top has to equal 0. So these expressions that I have up here, these equations, are equivalent equations. This is only true if that's true. This is easier to solve, so let's solve this. Does anybody know how to factor negative 2t squared plus 2t plus 2? I'd be impressed if you could, because it's not factorable. Okay, so you can't factor, right? So what do we do to solve a quadratic function that's not factorable?
Take out the negative 2.
All right, let's do that. So if I divide everything by negative 2, I'm going to get t squared minus t minus 1 equals 0. Okay, I still have a quadratic function equal to 0 that can't be factored. How do I solve it? Quadratic form. So t is going to equal, okay, minus b goes here, that'll be 1, 2a goes here, that'll be 2. b squared minus 4ac is going to be 1 minus 4 times 1 times negative 1, which is 5. 1 plus or minus 5 over 2, or 1 plus or minus the square root of 5 over 2. Anybody know what that is, 1 plus the square root of 5 over 2? 1.618.
That's what I was
Is that what you're going to guess?
Yeah.
Oops. See how close I am. Oh, 1.618, amazing. All right. Anybody know the significance of 1.618?
It's important.
Anybody know what 1 minus the square root of 5 over 2 is?
7. Negative 1.6.
Almost. It's negative 0.618. Oops. Gotta get used to this calculator. There we go. Divided by 2. Oh. Okay, 1 plus the square root of 5 over 2 is called the golden ratio. Just is. It's a magical number out there. Have you heard of a Fibonacci sequence? That's just a sequence number that if you take the first two numbers, whatever they are, let's say 1 and 1, add them up, next number is 2, add those last two numbers up, you get a 3, 2 and 3 make 5, 3 and 5 make 8, 5 and 8 make 13, 8 and 13 make 21. If you take a Fibonacci sequence as far as you can go, take the last number divided by the one before it, you get the golden ratio. If you take the next last one and divide it by the last one, you get the 0.618. You get, of course, negative this time. 1.618's reciprocal is 0.618. 618.033.0989 to the negative first is 0.618034328. Basically, kind of interesting, right? Little number theory thrown in there for you. But anyway, it doesn't have to be the golden ratio, it just happened to be, so I just threw that in there for you. So t is equal to 1.618 and negative 0.618. Which one of those two numbers is not important to us?
The negative.
Because?
It's negative.
Because everything starts at 0. Every one of these problems starts at 0. 0 to everything. All right, anything happening before 0 is irrelevant to us, so we throw it out. So the correct answer to question C, when does the particle at rest? When is it rest? 1.618 seconds is the right answer. So again, this thing's moving in some direction for the first 1.618 seconds, and then it switches direction. I don't know which direction it's moving yet, so we can figure that out in part D. Okay, part D is what it was last time. Part D, we're going to start at 0 and go to 1.618 seconds, and then from 1.618 seconds up to infinity, because it doesn't stop again after 1.618 seconds according to our records. Give me the direction on this interval, 1.618 to infinity. Do we know which direction it's moving?
positive.
2.
Yes, I know.
So what number could I pick in here to figure out where it's going?
2.
I could pick 2. What else could I pick that maybe we already evaluated somewhere?
Three.
Part B?
3.
3. All right, again, if I pick T, we already evaluated V of 3, right? We saw V of 3 to be a negative velocity. So here, its velocity is negative. Again, I don't care about the number as much as I care about the sign. Negative 1/10 if you care about the number, but negative is what's important to me. From 1.618 to infinity, this thing's going to the left,
Cross it out.
which means from 0 to 1.618, what's it going?
Positive.
Maybe. It could be going to the left there also. Again, it could be going to the left, stopping, and then going to the left some more. I don't know. I don't know until I actually test it. But if I try t equals 1, between 0 and 1.618, put 1 into this expression here, I'm going to get v of 1 is going to be negative 2 plus 2 plus 2, which is 2, over 2 squared, which is 4. That's positive a half, right? Again, the number's not as important as the sign, so Chris was right when he said positive, but again, it's positive because that's what the numbers tell us, not because we think it's got to switch. All right, so be careful of that. As far as question D is concerned, when is it moving in the positive direction? The answer is from 0 to 1.618 seconds moving in a positive direction. So this thing starts off going this way, then turns back and goes the other way for the rest of eternity. Any concerns with parts A through D for anybody? Just take this and shrink it up a little bit. Take all of this, maybe, there we go. Shrink it up a little bit. Do that more. There we go.
That's weird.
It's like, I don't want to go over there. I want to stay over here. There we go. All right, there's everything we've done so far. All right, so let's move on to E. Total distance traveled. So for part E, without going through all that explanation again, what 3 S's do I need to figure out? S of what?
0.
0, S of?
1.618
And S of?
8.
8. Why do we do S of 8?
Because it says.
Because it says 8, right? If it says 9, go S of 9. If it says 25, S of 25. So the last number is arbitrary. It's picked by the book. The first number is always 0, and the middle number, again, middle number or numbers, anytime it stops, which we found it to stop only at 1.618 seconds. All right, from 0 on up. All right, S of 0, S of 1.618, S of 8. I don't want to evaluate that function. Can't even see that function. That function and all these numbers. So I'm going to use my calculator to do it for me. So I'm going to type in my calculator, parentheses 2x minus 1, end parentheses, divided by parentheses, x squared plus 1, end parentheses. If I have an uglier function like this, and I have to evaluate it at multiple numbers, I try one more time. Go over there and stay. Oh, there. I'm just going to use my table to do it for me. So 0, 1.618, and 8. So I got negative 1. I've got 0.618, that's interesting, and I've got 0.231. Alright, so I know exactly where it's at each of those moments, approximately where it's at. I rounded 3 decimal places, but, okay, how far did it go from negative 1 up to 0.618?
1.618.
1.618. How are we getting that number?
Adding
Actually, we subtract. Take the big one minus the small one, that's how you find distance. And we want positive distance, that's why I'm going to do big minus small. So if you weren't a good subtractor, as David did just mentally in his head, good job, David. But if I take the big number 0.618 and subtract the small number negative 1 equals 1.618. What's the big number between 0.618 and 0.231? 0.618 minus 0.231 equals 0.387. I have no doubt that all of you have the capacity to subtract fractions, but it's inefficient. Calculator is more efficient. So feel free to use a calculator. If it was negative 2, 3, and 6, I would probably expect you to do that in your head. Start getting to decimal subtraction, maybe, especially with this, some borrowing necessary, that kind of thing. Use a calculator to save some time and energy. You know how to subtract fractions and decimals and stuff like that. You made it all the way to calculus. So I'm not really that concerned with your ability to subtract decimals at this point. Save some time with the calculator. Same deal with adding. That's how far we went in the first 1.618 seconds. That's how far I went in the last 6.382 seconds. If I add those up, I'm going to get 2.005, I think. Should have said that on camera just in case I'm wrong. 1.618 plus 0.387, 2.005 feet. For part F, started here at S equals -1, went up here to S equals 0.618 at T equals 1.618, ended up here, T equals 8, S equals 0.231. There you go. There's our diagram.
0.231. Just 0.231.
It's 0.231. I probably should have slid that a little bit further over.
That's okay.
I got caught by the bell there, so I wasn't thinking as well as I could have. But again, it starts here, goes up to 0.618, then goes backwards and ends up at 0.231 at 8 seconds.
You have to put dots at where it meets.
I want dots, yeah, dots where these points are. Yep. And then arrows along the line to demonstrate the motion of the particle. All your homework problems have these questions, different functions, so be prepared for that. Get that done tonight.